A good day, students and viewers. We are going to continue with our chapter 1, and I think this would be our last video where we are going to discuss rules of power of this thing. So, rule of exponents for this is 1.6, and this talks about laws of exponent. Exponents of real numbers, of instead of it says for real numbers. Okay, so we are going to talk about real numbers, and we will discuss about what is known as exponents. Many cases exponents are also said as powers. Exponent is same as a power. What is that power means? Let us take x. Okay. Now x to the power 0 we know is equal to 1. That all of us know, and we have done it before. So what would be the x to the power 1? That would be x. Okay, what is x to the power 2? That is, to the power means multiply the same base. This is called base. This is called base. And this is called, as I said, exponent or power. Don't get confused. Okay, so here the base is x, the same base to the power 1. So it's x to the power 2 means what? X into x, not x plus x. Okay, x into x. So in case of conception, what does it mean? What does it mean if I have x on this side? If I have x on this side, then I get the area as x into x. So area would be x into x, that is equal to x square. We all know about it, but I am just going to make it totally clear so that there would be no confusion in your mind. Okay, now let's see what is x to the power further one. Let's develop this further. So if I write now x to the power, okay, the top part I don't need it also, because this I have already told you before. So this would be again, if I said x to the power 3 would be x into x into x, that would be x cube. So similarly, what would be x to the power n? That would be x into x into x, so many times up to n terms, up to n terms. Okay. Now, let's see, there are some rules and regulations regarding this. Say, for example, if I have x to the power 2 into, say, x to the power 3. Since the base is same, then I can write x 2 plus 3, that is equal to x to the power 5. Okay, so let us see, there are some examples which have been given in the book, and let us take it this way. Okay, so one rule is, I will take it up like this. So this we understand. I think we should first explain the rules, and then I will do the what you called the sums as it has been given in the book. So I will reverse the order. First, let us discuss the rules. Let us say a to the power m into a to the power n. Base is same. So then what I can do, A equal to m plus n. Okay, so I can write also this is rule number 1. What is rule number 2? A to the power m, if I again do it a to the power n, what does it mean? What it means, a to the power m into a to the power m into a to the power m into like that up to n terms. Okay, so if we take the previous one, then I can write this one a to the power m into n. So this is the same thing you have done it. So this is multiplication, okay? A to the power m into n, or you can also write a to the power m dot n. You can also write like this. Okay, now there is rule number, I am going up so that it becomes within easy for coverage. So it would be, what would happen, a to the power m divided by a to the power n. What would happen? Now let us do one thing in this case. We will do it as this would be a to the power m minus n. Why it is like this? We'll do it a little bit differently, and then it can be seen that if I multiply by a to the power, okay, now okay, we'll do it from here. How this is comes about, and this is a second one we will take up. That is a to the power, this is number 4, let us take it. This is a to the power m, see this. Now another base comes in, a to the power n. And no, that is a to the power m. So the base is different. So this is base is different. Base is different. Okay. Okay. But power is same. Both are m. So power is same. Right? So in this case, how can I write it? I can write AB, A into B into M. So understand this one very carefully. So I am multiplying this thing because the power here is same. Okay, now let us do it this way. Let us start with this one and do a very meaningful concept. Okay, let us take m equal to, in this factor, this we will further process it. Let us take here m equal to 0. What it happens? Let's see what it is. So it becomes a to the power 0 because m I have taken 0. Then it becomes an, and then here it becomes a to the power 0. M is 0 minus n. So a to the power 0 is 1. So this will be equal to 1. And this should be a to the power n. So that this not be equal, this would be the following up. So you can do it, give this signal. So this would be a to the power minus n. So when I flip it over, that means when I take it up, so the negative sign comes. So it becomes a to the power minus n. Flip it over. So I am taking this one, and the denominator is going to numerator. Denominator is flipping up, is going to numerator. Okay, so this concept is clear. That means, what is that concept? That if I have 1 upon a to the power n, I can take it as a 1 upon a to the power minus n. Okay, let's develop this further. 1 upon, say, a to the power 3, that would be equal to a minus 3. So these concepts are clear to you. Okay, now here there is certain things, so I have to say that here in this case, definitely this to remain positive, m should be greater than n. Okay, but most of the cases it will be like this. I hope these concepts are clear, and based on this concept we will do some sums or examples which are given in the book itself. Okay, so let's do those. I am using a bigger font in order so that it's easily, you can easily view it. Otherwise I could have covered much more, but I was thinking that if I use a smaller font, there would be a better perception. Okay, let's do it. How do I do it? 17, this is, there's no example is not given. 17 square dot 17 to the power 5. That's what should I check up first. The base is same. So it should be 17 plus 2 plus 5, that is equal to 17 to the power 7, or exponent to the power 7. Okay, 5 square into 7, what would be? 5, 2 into 7, that is 5, 14. Okay, then 23 to the power 10, and below is 23 to the power 7. How do I do it? So I will do it 23 to the power 10 into 23 minus 7, that is 23 into 3. Okay, now let's see. So there, all these cases we are examples we have taken, the base has remained the same. Base has remained the same. Let us do another example of the other one. Okay, where the base is different, but power is same. Okay, now let us do that. Okay, so that would be your number 4. That would be your 7 into 3 into 9 into 3. So these powers are same. So what I can do, 7 into 9 into the power 3, that is equal to 63 to the power 3. So these are simple and easy to understand. Let us do again certain these things. Same things, it's given in differently. Okay, so another example, for example, what we have done, we can do it 17 to the power 2 into 17 minus 5. So that would be, the base remains same, 17, 2 minus 5, so 17 minus 3. Okay, there is no problem in this. We can also write this one 1 upon 17 to the power 3, because as it goes up, then if I flip it down, then this sign changes. The sign here, this sign changes. I hope you have to understand and remember this. You cannot think about doing it differently. Okay, now next example we can go, and that will be, instead of rubbing it off, I can take up another one. that is 23 to the power minus 10, and this is 23 7. So what we will do? So generally we want to keep everything on the numerator, so I will take 23 minus 10 into 23, this will flip over, so sign changes, 23 to the power 7, so that will be added up because the base is the same, minus 10 minus 7, that is equal to 23 minus 17. Okay, there is no issues on this. Okay, let's take another one of these, that is I have done 23. Now again number 4, that comes out 7 into minus 3 into 9 into minus 3. Okay, minus 3 same, but the base changes. So what we will do? 7 into 9 into to the power minus 3, that would be 70, that will be 63 to the power minus 3. So there is no addition here. So remember this, don't go and make it 6. No, minus 6, no. It is only this base is this thing. The minus 3 remains same. So this is not minus 3, minus 6, no. Okay, now let's see what happens when we have fractions. That means what? We will do another set of examples. These are very important, not only in your class, in class 10 or in other class 11. These kind of questions with power, or that is called exponent, will keep on coming. Okay, let us see. Following competition. Okay, now here we are going to do, okay, so again this you must, another exponent and the radical sign. So how we used to use radical sign? Radical sign we used to as like this, right? So this means square root. So let us say this is square root of a. So I can, in form of exponent, I can write a to the power half. That would be shown like this. Let us say I write 3 like this. That is cubic root of 3. I can write a into 1/3. So nth root of a would be a to the power 1 by n. So this is the relationship between the radical sign and the way that you can also express your exponent. Okay, so that will be that has been taken up. So let us do it this way. Here, yeah, okay. In the book, I was looking for some example in the book, and there is a very nice example. This is, say, let us take 4, and that is 3 by 2. So how I can do it? What are the ways I can do it? First of all, I can separate it and say this is 4, this is cubed, and then this is also done into half. Okay, what is the cube of 4? That is 4 into 4 into 4. That is equal to 64. And, okay, no, this is not equal to. That's 64. Okay, and that is to the power half. Okay, so what is this? This is 64 to the power half. That means square root of 64, that's equal to 8. Right? Or I can do it another way, the same thing. I can, so what I did, I first operated on 3. I took operation of 3. I made it 64 and then I allowed the operation of half. What happens if I do this one first? That means what? If I do 4 into 3 by 2, I will do it this way. First, I will do 4 into half and then I will do it to the power whole to the power 3. Okay, half of 4 is root of 4, that is 2, and that would be multiplied, that will be exponent 3, that is 2 into 2 into 2, that is equal to 8. The same thing. So it doesn't make any difference which way you do it. So this, you can also add another step here. So this would be like I have done it, 4 cube and half of that. You can do it to reduce your confusion. Okay, so then once we have done it, let us see how we do these things. Okay, other rules remains the same rules, only these things, this power and the relationship between the radical sign and exponent, I have explained to you just a few minutes ago. Okay, let's go on. Doing the next one. And this is 2 to the power 2/3, okay, into 2 to the power 1/3. Okay, the basis remains the same. So I can add up 2 to the power 2/3, this 3 should be, plus 1/3, that is equal to 2 to the power 1, that is equal to 2. 2/3 plus 1, this is 2/3 plus 1/3. Okay, now, now these are part of, again, now this is little bit confusing here in the book, so don't get lost. This is example 21. That has come previously as this thing. The same thing is being repeated here. So this is number 1. Now number 2, I will do it 3 to the power 1/5 to the power 4. So multiply by this into 4. So that would be 3 to the power 4 by 5. Simple. Nothing there to it. Okay, number 3, that comes out 7 to the power 1/5 divided by 7 to the power 1/3, that is equal to 7 to the power 1/5 minus 1/3. Okay, so how would you do this? So one way is this, what? The base, there is the same base, so I have done it, only this I have to do it. So 7 to the power niche would be 15. So this should be divided by 15. This would be divided by 3 minus 5. So that would be 7 to the power minus 2 by 15. 7 to the power minus 2 by 15. Done? Okay. Again another example. And another example we will do it. This example is here. We will erase it and do the example. Okay, now this comes out to be a little bit similar thing. 13 into 1/5 into 17 into 1/5. Base is different, but power is the same. So what we do? We multiply 13 into 17 and raise to the power 1 by 5. Right? Raise to the power 1 by 5. What is 13 into 17? Or 17 by 13? This is 51 into 17, 1, 2, 2. 2 to 1, so this is 2 to 1 into 1 by 5. Okay, that completes the exercise. Okay, now let us go and finish it up, and that is exercise. This was example, and exercise is 1 point is this one, and this I will finish it. There is not much, not many, so you don't have to exercise 1.6. Okay, definitely we are following the same textbook so that there is no confusion. So it says question number 1, it says find, and it gives you 3 numbers. One is 64 by half, that is practically root of 64, that is equal to 8. You don't have to worry about that. 2, that is 32 by 1/5. How will you do it? I will do it 35 into, I'll do it 2 into 2 into 2, right? That would be what? 2 to 8, 16 into 2 into 2, right? 4, 8, 16 into 2 is 35, it's 1/4, so I select only 1, 2, that is equal to 2, because I have to do it 1/5 time. So done? Okay, this is so simple that you may say, well, we are doing class 3 questions. Maybe it's not actually class 3, 125, but you can see once you understand something, anything becomes easy. So what is it? It would be, so this is cube root, this is 5th root, this is square root. Only thing it is represented. I could have also written it root to the power 64. I could have also written it root to the power 32 by this is 5. I could have written it this way. But removing root and writing it like this becomes more simple and more easy to do this. So what would this would be? This would be 5 into 5 into 5 to the power 1/3. So I will pick up only 1 5. So this is equal to 5. So question number 1 is over. Now we will go to question number 2. Question number 2. Again it says find and gives is another. Now this is here 4 sets of number, and that will be finished in a jiffy, because I now you understand all the rules, all the laws. Here it says laws of exponents of real numbers, okay, or powers of real number. Many times this power and exponents are used interchangeable, right? 1 is 9, 3 by 2. Okay, now how do I do it? As I said, I can do it 2 ways. First of all, I think it is easy to do this. So 9, I will do it to the power half first, and then I will cube it. Okay, 9 to the power half is 3. 3 into 3 is 9. So square root of that, this is square root. So 3 to the power 3, that is equal to 3 into 3 into 3, that would be equal to 27. Done? Okay, number 2. Number 2 is 32 to the power 2 by 5. Okay, now again, this is 1/5 root and square. So we have done it differently here. We can do it the other way here also. We can 32, we will do it first 1/5, then we will square it. Okay, 32 1/5. 2. 2 into 2, we have just done it in the previous example. So that would be 32. So we have to do 1/5 of this, and then 1/5 of this, and then I have to square it. Okay. So 2 into 2 is 4, 4 into 2 is 8, 8 into 2 is 16, 16 into 2 is 32. So take one of them. So this should be 2 and 2 square. So 2 into 2 would be equal to 4. So done. Simple questions. But if you do not know and if you do not attack it properly, you would be losing a lot of time. So be careful about it. So let us finish off the other part of it. So this would be our I have done up to 2 to the power 3. I have done 32. Now I have to do number 3. I was getting confused which I have done before and which I am doing it after. To the power 4. Okay, remember we just did one of this. So same thing, this I will do it 16 to the power 1/4, and then I will cube it. Okay, 16 to the power 1/4, 2 into 2 into 2 into 2, and this will be 1/4 of this, and then I have to cube it. 1/4 means 2 into 2 is 4, 4 into 2 is 8, 8 into 2 is 16. So we are here, so we take up only one of the two, 2 to the power 3. So 2 into 2 into 2, 4 into 2 is 8. Done? Okay. Let's finish the fourth one. Fourth one is easier than this. 1, 2, 5. It is 1 upon minus. So be careful. Minus 1 upon 3. Okay. So why don't you do it this way? So this would be, I will do it 125 by 1/3, and then I have to flip it over because minus 1 is there. So this would be 5. We have just done before. That is equal to 5 into 5 into 5. For completeness, I am again repeating it into 1/3 into 1/3 into to the power minus 1. Okay, that is 5 to the power minus 1, that is 1 upon 5. Okay, so this is done. This is question number 2. So we will now go to question number 3. Okay. Now we are going to do question number 3. Their language changes a little bit. It says simplify. It says simplify. And it gives 1, 2 to the power 2/3 into 2 to the power 1 upon 5. Okay, what I have to understand that, or what I have to notice, that the base is same. So I will do 2 and then I will add up the power or the exponent. So this should be 2/3, and I have to ensure whether there is any negative or not. No, there is no negative. So I will do it this way. So 2 to the power, this would be 15, this would be 10, and this should be plus 3. That would be 2 to the power 13 by 15. Right? This is 15 when you go, this is 10, and this is 3 to the power 15. I'll go to the next one. And that is 1 upon, 2 to the power 3 into to the power 7. So I can do it this way. that, and you can do it. You can either flip it up, so that would be 3 to the power minus 3 and into again 7. So that means it should be 7 times this. So 3 to the power minus 21. Or you can do it first 1 upon 3 to the power 3, or you can do it or to the power 7. Both are this thing. So you can do it for the first time. So that should be 1 into 3 into 3 into 7. That is 1 upon 3 into minus 21. No, why it's 21? It's 21. Yeah. So this should be 3 to the power minus 21. I was going ahead of myself. Okay. Okay. So that is number 2. What is number 3? Okay. That takes care of number 2. So let me take care of the next one, and that is number 3. And number 3 says like this: 11 to the power half into 11 to the power minus this thing. That is equal to 11 to the power half minus 11 to the power 14. That is equal to 11. What it would be? It will be 4, because this is 4. This should be 2. This should be minus 1. So this is 11 to the power 1 by 4. If you take 1/4 from 1/2, so that would be definitely 1/4. Right? So this is, you can do it by verbally, but I just did it so that you see that in case of any number, you got to do it like this. Okay, the last one, that is 7 to the power half into 8 to the power half. So that base is different, but power is the same. But this and this is power to the same. So what I will do 7 into 8 to the power half. That is 56 to the power half. So this completes our chapter on chapter 1. I will take a little bit of time to explain certain things which is, I think, needs to be little bit explained, not only for my channel but for everyone's information. See, if you see, this is a video which will be put up in YouTube. YouTube channel, right? Channel. So there are two things comes in. One is like or dislike, and other is subscribe. So if you like the channel, you click. You can also dislike the channel. So you can have a like, dislike, and you can have a comment. So you can use all of them or one of them. You have to select one of them. Or after dislike also you can make a comment. So you have to choose one of them. Subscribe you do so that any video I upload, it will be, you will immediately get that video. So you don't have to look for it. You don't have to look for it at all. So I have got lot of likes, but I do not know why people who like it, why don't they subscribe also? The subscription is an important part of it. So you please subscribe to the channel, and you like. I am lucky, I have got a lot of likes and I have got a lot of views. So people are viewing my channel. They are not choosing any one of them. and neither they are subscribing. I am unable to understand if they don't make a comment the reason for their not subscribing. This subscription is free. You don't have to pay anything. And you continue getting whatever put up in my video, you will continue getting it, whether it is. And my video is mostly on mathematics. I have not gone into physics and chemistry. So in my next one, I think I will take up quadrilateral. Quadrilateral. And this will be put up, and I think a lot of people will be looking for quadrilateral, but I think there is a requirement. I asked a student of class 9, he says yes, quadrilateral you should take up. Thank you and have a nice day.